Hello folks, welcome back to Merrill Math. I'm Mr. Merrill, and today we're talking about absolute value inequalities. So we're combining the ideas of the last two videos into this one. Now these look a lot more intimidating than they are, but the first thing you want to remember is absolute value is the distance from zero, and as long as you can remember that, you can find your way through these problems. So let's jump right into an example here. I think I have the rest of the page to look at. So we've got the absolute value of x minus 3 is less than 8. So what this is saying is this distance here is smaller than 8. So what that means is it could be anything up to 8, but not including 8. So it's all of this stuff in between. So this is sort of leading us to that idea of an and statement. So it's the stuff that's in between here. So how do we split this up? So we did that in the equation video. We split them up into two separate parts. So the first one, unsurprisingly, we write it exactly as it is. X minus 3 is less than 8. The second one is what I like to call keep, change, change. You might be familiar with something like that when you're dividing by fractions, keep, change, flip. This is sort of the same idea. We're going to keep this x minus 3 because we always keep the stuff that's in there. This is going to switch to greater than, and this is going to be a negative 8. Now, if you don't remember that, as long as you remember the distance, you can remember which direction you're shading. This is to the right of negative 8. So that's what this says. Shade the stuff to the right of negative 8. Now, we can solve these. So we're going to add 3. And the steps are the same all the way across, so we can just sort of batch them out. So we have x is less than 11, and x is greater than, so we have negative 8 plus 3, that's going to be a negative 5. So as long as we pick values that are greater than negative 5 and less than 11, we'll have something that works. So some value in between here. So if I pick 11 or something less than that, so like 10, 9, 8, if I pick 8, 8 minus 3 is 5, well that is less than 8. If I pick something greater than negative 5, so like, I don't know, 0. 0 minus 3 is negative 3. The absolute value of that is 3, which is less than 8. That is a valid statement. So they look a lot scarier than they are. That's the thing to remember about these problems. So let's take a look at some more examples while I hit the microphone with a marker. Okay. Example 2. We have 2x minus 3 is greater than or equal to 5. So the distance from 0 that this is that this statement, this expression, is 5. So it could be at negative 5 or it could be at positive 5. And it's greater than, so which means that the solutions we're looking at are to the outside. So this is similar to what we've seen as an or statement. So let's split this up and solve it. We've got 2x minus 3 is greater than or equal to 5. We've got 2x minus 3, keep, change, change. So we're going to change that to a less than, and we're going to change that to a negative 5. Going to add 3. And again, all these steps are the same all the way across, so we can batch them out. So we've got 2x is greater than or equal to 8, and 2x is less than or equal to negative 5 plus 3, that's going to be a negative 2. So we divide both of these by 2, so x is greater than or equal to 4, and x is less than or equal to negative 1. So if we wanted to graph these, we could, but notice we're picking numbers that are outside. So greater than 4, so to the right of 4, and less than -1, so that would be to the left of -1. Okay, that is that one. Now let's take a look at this. So here we have, let's see, the absolute value of 4 minus x is less than or equal to 8. So if we want to solve this, we approach it the same way that we did before. We write it without the bars. 4 minus x is less than or equal to 8. And then we've got 4 minus x is, so keep change, so greater than or equal to -8. All right, so we're going to subtract 4. Something might be jumping out at you right away, and that is the negative sign in front of the x. So it's going to try to throw a wrench in the gears, but we're prepared for it. So we've got a negative x less than or equal to 8 minus 4, that's going to be 4. Negative x greater than or equal to -8 minus 4, that's going to be a -12. Now we have to divide by a -1. So when we divide by a -1, these signs flip and these signs flip. So we have x greater than or equal to -4, and we have x less than or equal to a +12. So if we graphed that, we don't have to, but here's 0, here's -4, here's 12. So less than or equal to 12, so we've got that, greater than or equal to, so we can include this point. We're shading to the right of this and to the left of that. So it gives us what appears to be an AND statement. Okay. That is all I have for those. If you have any questions, comments, points of clarification, you can leave those in the comments below. If this video helped you out at all, you can hit the like button. If you would like to see more of these, you can subscribe. Otherwise, thanks for watching.